All right, today I'm going to talk about how to write a quadratic equation from a form that looks like this, which is called standard form, into vertex form. So the most important thing that you want to know when you're doing something like this is what does vertex form look like and what makes it correct? How do you know if you're right? So from there, you can start to develop some strategies. Now, if I was going to write something in vertex form here, let's say I wrote this. Okay, here's an example of a vertex form equation. Now, how would I be able to tell if this one and this one were equivalent expressions? That's what we want to be able to do. We want to make sure that this equation and this equation mean the same thing, that they're equivalent. So how can we check that? Well, what we can do is we can actually rewrite this. We can simplify this and multiply it out and see if it equals, that's right, we can simplify this. We want to use PEMDAS, or the order of operations. And what that means is we're going to deal with our parentheses first. There's nothing we can simplify in there. So we go to exponents. We're going to simplify this exponent. And we can see that the exponent is really just telling us to multiply two copies here. You can use your favorite method of multiplying binomial expression like this. There's different ones. A very popular one is FOIL, but you can use a different one if you want. You get x squared plus 2x plus 1 minus 7. Okay, so exponent's done. We want to work on multiplication after that. So we're going to distribute this 2. You get 2x squared plus 4x plus 2 minus 7. And then we can combine these two using addition. So 2x squared plus 4x minus 5. And we can see now, because these are in the same form, we can compare these two and we can say, you know what, they're not the same. So by taking a moment and kind of analyzing why they're not the same, you can start to develop a strategy as to what can work and what won't work. So for instance, we can take a look at, let's take a look at just this first part, right? Why doesn't this match this? Well, the only part that doesn't match is the 2. And if you kind of trace back through the problem, you say, where did this 2 come from? Well, we can track it here. We can track it. We can see it came from this 2 getting distributed, which came from this 2, which came from this 2. So we wanted this number to be a 3. Therefore, when we write our vertex form, that gives us knowledge that whatever number is this leading coefficient, that should match this coefficient here. And so we can reason through that this should actually be a 3. So let's try again. Maybe we just put a 3 in there. Let's try something like this. Maybe that'll work. Again, we'll simplify. Something like this. Let's leave a space so it's not as clumped together. Use your favorite method of multiplying here. We get x squared plus 10x plus 25 minus 2. Distribute the 3, we get 3x squared plus 30x plus 25 minus 2. 3x squared plus 30x, and then these two can be put together to give us 23. Okay, we can see now, if we compare this one and our original, we can see now we have a 3x squared. So that part matches. Now we can look at this next part. This says 30x. That one says 12x. Let's think about why is this 30x and what could we have done differently to make it into a 12x? So this 30 came from when we distributed the 3 into this 10. And this 10 came because when we FOILed it, we ended up getting 5x and 5x. So how can we use that to our advantage so that we end up with a negative 12 here? Well, what we probably want to do is we probably want this to be a negative 4x, because then, instead of a 10x, because then when we multiply 3 times negative 4, this will be negative 12x. Negative 12x. And in order to get this negative 4x to show up, we would want these to be minus 2's. Right? So this would have to be a minus 2. So that gives us a little bit more information. So let's take a look now. We know that we're looking for 3 times x minus 2 squared. Let's just put plus 5 here. We don't know if this 5 is correct, but we can always just go back and check. So let's go ahead and multiply this out and see what we get. 3 times x minus 2 times x minus 2 plus 5. This gives us 3 times x squared minus 4x. There's that minus 4x that we knew we wanted. Plus 4 plus 5. 3x squared, or we're going to distribute this. So 3x squared minus 12x plus 12 plus 5. Okay. Put together the 12 and the 5. You get 3x squared minus 12x plus 17. Okay. Comparing this 17 to this 98, we can see we're almost there. In fact, I'll try and zoom out here so that you can see. You can see we almost have it completely matching. Right? You know what part doesn't match is that this is a 17. We want it to be a 98. But we do know. So we know that this 12 is kind of a byproduct. It's like a side effect of having this minus 2. We can't not have this 12. The fact that we have this minus 2, we need this minus 2 in order to get that negative 12 that we had before. And if we have that minus 2 there, it means we're always going to get a plus 4 right here. So this 12 will always be here. What we need and what we can change is we can change this 5 so that we can get to 98. And if we change it here to be 86, 12 plus 86 is going to give us 98. And that 86 means that we would want that all the way back here. And so finally, we can say y equals 3 times x minus 2 squared plus 86. This is the correct vertex form because it will equal this. Now, as you work through this strategy, this is sort of the beginner strategy. It involves a little bit of guess and check, but also a little bit of logical deduction and working backwards. This is real problem solving. As you do this strategy more and more, you're going to develop more sophisticated and more advanced strategies. I'll put another video up that shows one of these more advanced strategies. But yeah, this is kind of your foundation. From here, you can notice patterns. From here, you can notice shortcuts, and you can find ways to get this even faster. Okay, good luck, everybody.